You know, every single second of your life, a silent, invisible war is being fought inside your body. The stakes? Well, they couldn't be higher. It's literally a matter of life and death. So let's pull back the curtain on this hidden world and meet the microscopic guardians fighting for you, right now. Seriously, as you're listening to my voice, your body is being invaded by bacteria, by viruses, just countless microscopic threats. So the question is, who is on the front line? Who is fighting this battle for you? The answer is your immune system, an absolutely incredible, complex, and, well, beautiful internal army. So here's our game plan for this explainer. We're going to follow an immune battle from the very start to the finish. We'll kick things off with the constant threat we're always under. Then we'll check out the body's fortifications. We'll meet the first responders who rush to the scene, and then the elite specialists they call in for the really tough fights. We'll see how they develop this amazing memory, and finally, we'll look at the dark side. What happens when these powerful guardians go rogue? Okay. First things first, let's set the scene. Let's paint a picture of the battlefield, and trust me, it's not exactly a peaceful place. We are basically swimming in a sea of pathogens. These are any microorganisms that can make us sick. We breathe them in, we eat them, they're on our skin. The only reason you're not sick all the time is because your immune defenses are so ridiculously efficient that most of these invaders get wiped out before you even have a clue they were there. So what is this first line of defense? Well, a great way to think about it is to picture your body as this medieval fortress. Its number one job, just keep the enemy out. And the walls of this fortress? They're what we call our epithelial surfaces. These are the thin layers of cells that line everything that touches the outside world. So your skin, the inside of your gut, your lungs, they're designed to be a tough physical barrier, the very first roadblock any pathogen has to deal with. But this isn't just some boring old wall. Oh no, it's a super sophisticated three-layered defense system. First, you've got the mechanical layer. The cells are packed together super tight. Then, you've got a chemical defense. These surfaces are coated in proteins that are basically poison to invaders. And get this, there's a microbiological defense. Your body is home to tons of helpful bacteria, your normal flora, who actually help fight off the bad guys by crowding them out. But hey, no wall is perfect, right? Sooner or later, a pathogen finds a way through. Maybe it's a tiny cut in your skin. You can see that breach happening right here in the second panel. That's it. That's the inciting incident. Once it's in, it starts a local infection. And that single breach sounds the alarm that kicks the entire immune system into high gear. Okay, the wall is breached. The alarm bells are ringing. It is time to call in the first responders. And that brings us to the innate immune system. The word innate just means you're born with it. Think of this as the body's ancient rapid response SWAT team. It doesn't really care what the invader is, it just knows it's not supposed to be there. Its job is to get there fast, hit hard, and contain the threat immediately. One of the star players here is a cell called a macrophage. These guys are like the cops on the beat, constantly patrolling your tissues. When they spot an intruder, they do two critical things. First, they literally eat it. They just engulf the pathogen. And second, just as important, they start screaming for backup by sending out chemical alarm signals to the rest of the immune system. The first responders are doing their best, holding the line, but sometimes the invasion is just too big. They've called for backup, and now it's time to bring in the special forces. This is the adaptive immune system, and unlike the innate system, this one is not generic. This is where things get personal. It develops a custom-made attack plan for one and only one specific pathogen. And its most incredible trick? It remembers every single enemy it has ever defeated. Now let's talk about one of the biggest challenges for the immune system. What happens when a virus gets inside one of your own cells? It hijacks it, turns it into a little zombie virus factory. So here's the puzzle. How do you kill the enemy when it's hiding inside your own people? The answer is a true specialist. The cytotoxic T cell. Think of it as a trained assassin. It has the incredible ability to tell which of your cells has been compromised. It hunts it down, latches on, and delivers a lethal hit, a kiss of death, that kills the infected cell and all the viruses inside before they can spread. It is surgical precision on a microscopic scale. It's just amazing. But what about the enemies that aren't hiding inside cells? The ones just floating around in your blood or tissues? For that, you need a different kind of specialist. Enter the B cell.
B cells are basically mobile weapons factories. They churn out millions and millions of tiny, Y-shaped proteins called antibodies. These antibodies flood your system like guided missiles, finding and latching onto pathogens to neutralize them or mark them for destruction.
So the battle is won. The invaders have been cleared out. But for the adaptive immune system, its most important job is actually just beginning. You see, after the fight is over, some of those heroic B and T cells that fought the battle, they don't just disappear. They stick around for years, sometimes for your entire life. These are memory cells. They are the grizzled veterans of this war, a living library of every enemy you've ever faced. If that same pathogen dares to show its face again, these memory cells are ready. They launch a counterattack so fast and so powerful, you probably won't even realize you were infected. That, right there, is immunity. And this whole idea of memory is exactly how vaccines work. They're like a training exercise for your immune system. They introduce your body to a safe version of a pathogen, so it can learn to fight it without a real war. Live attenuated vaccines use a weakened but still living virus. Think of it like a live sparring partner. It gets inside your cells a little, which wakes up a full-scale response, including those T-cell assassins. Now, killed vaccines use a dead virus. This is more like giving your army the enemy's blueprints. It's super safe. But because the virus is dead, it can't get inside your cells, so you don't activate those T cells. This might mean you get a slightly less powerful long-term memory. And that's the trade-off, really, potency versus safety. Speaking of protection, this graph tells such a cool story about the start of our lives. Look at the blue line. Those are protective antibodies a baby gets from its mom. See how high they are at birth? But watch what happens. After birth, that borrowed protection starts to drop off. At the same time, the baby's own immune system, that's the red line, is slowly learning to make its own antibodies. And that gap, right in the middle, creates what's called a window of vulnerability around 3 to 12 months of age. And that is exactly why vaccine schedules are timed the way they are, to protect babies right when they need it most.
So this system is powerful, it's precise, it's a lifesaver. But what happens when the guardians turn on the very body they are sworn to protect? Well, the system can fail in two really big and kind of opposite ways. First, there's autoimmunity. This is when the immune system gets confused and loses the ability to tell friend from foe, and it starts attacking your own healthy cells. We now know that mutations in just a single gene, like one called FAS, can trigger this. On the flip side, you have immunodeficiency. This is where the system is too weak or just doesn't work at all. A condition like SCID, for example, leaves a person defenseless, turning something like a common cold into a life-threatening emergency.
When you really think about it, your immune system is constantly walking this incredible tightrope, a razor's edge between protection and self-destruction. It has to be powerful enough to destroy any invader, yet gentle enough to leave your own body unharmed. It is our greatest guardian, but it can also be our greatest threat. And as we look to the future of medicine, that leaves us with one massive question. Can we ever truly learn to be its master?